Let's practice writing polynomials in standard form given some zeros. For number 1, we know that the leading coefficient of this polynomial is equal to 1, and we're given 3 different zeros here. Alright, now each of these are distinct zeros, meaning they are unique, so let's go ahead and see if we can write at least this polynomial to get started in factored form. So we're going to write f of x is equal to, we'll write this function, and then we're going to have this first binomial, since it's linear, going to be x plus 1, because that way this negative 1 would make it 0. Then we're going to have another binomial of x minus 2, that way the positive 2 would make that 0, and then we would have x minus 4. So technically we do have the polynomial now, it's just written in factored form. Let's go ahead and rearrange it a little bit so we can write it in standard form as well. So it doesn't matter which two of these binomials you start with, let's just go ahead and start multiplying out so that we can turn it into standard form. So I'm just going to start with these first two, right? So if we go ahead and distribute here, we multiply x times x, that's going to be x squared here. And then if we go ahead and multiply this x times negative 2, that's going to be negative 2x. And then 1 times x, that's going to be x. So negative 2x plus x is going to be a negative x, or negative 1x. And then finally, this positive 1 times negative 2 is going to be a negative 2. All right, so just from there, we're going to see that we have a trinomial. That's what we got when we multiplied those two together, those two binomials. And then we have this x minus 4 afterwards that we haven't used yet. Now let's just go ahead and multiply this trinomial by this binomial. So if we start off by multiplying this x squared by this x, that's going to be x cubed. So we can go ahead and write x cubed over here, then multiply this x squared over by this negative 4, that's going to be negative 4x squared. Now going on to this negative x multiplied by x is going to be negative x squared. And then if we go ahead and multiply this negative x by this negative 4, that's going to be a positive 4x. All right. Finally, this negative 2 is going to multiply by this x. Negative 2 times x is going to be negative 2x. And then this negative 2 multiplied by this negative 4 is going to be a positive 8. Now let's just go ahead and see if we can combine any like terms here. So there's nothing else that has a cubic degree here. Let's see if we combine this negative 4x squared minus 1x squared. That's going to be minus 5x squared. Okay, and then we can go ahead and combine over here this 4x minus 2x, that's just going to be a positive 2x, and then we have this plus 8 at the end that can't be combined, let's just leave that constant alone. So in the end of the day, we have this polynomial of f of x is equal to x cubed minus 5x squared plus 2x plus 8. So in the beginning, we were given 3 zeros of negative 1, 2, and 4. And those 3 zeros would be where the intercepts are, or the roots would be for this cubic polynomial that we just found. For number 2, we have another polynomial that's going to have a leading coefficient of 1, but in this case we have zeros that were given of 4 and then 1 plus root 5. Now, for this one, we want to make sure we understand that if we have rational roots, they just come alone, like this 4. However, we have an additional root here. If we have an irrational root like 1 plus root 5, we also have an additional one of 1 minus root 5. So be aware that even though we're given 2 roots here, we technically have 3. Let's go ahead and write our polynomial in factored form first. So we have f of x is equal to, and we know one of our zeros is 4, so our first binomial is going to be x minus 4. After that, we have this 1 plus the square root of 5. So we're going to write x minus and then keep that in parentheses. So that's going to say 1 plus the square root of 5. Let's just keep that all together. And then we're going to have one more binomial here of x minus the quantity of 1 minus the square root of 5. So basically we have x subtracting one of our roots of 4, then we have x subtracting one of our other roots of 1 plus the square root of 5, then we have x subtracting our last root of 1 minus the square root of 5. Whenever we have a pair of roots like these radicals, let's go ahead and deal with those together first. My suggestion is going to be to distribute this minus sign to both of these terms inside here, and distribute this minus sign into both of these as well. So ignoring the x minus 4 for now, let's just take this x and then distribute that minus. So we're going to have minus 1 minus the square root of 5. That's going to be this first parentheses. And then for the second one, we're going to have x minus 1, but then plus the square root of 5. At this point, what I think is useful to do is to regroup this. So let's go ahead and group this x minus 1 and x minus 1 at the beginning of each of these parentheses. Now at this point, it's important to remember one of our old patterns from quadratics. So we have this difference of squares patterns of a minus b times a plus b, right? If you were to multiply that out, you would get a squared minus b squared, right? Now this is similar. We're just going to consider this x minus 1 as a, which is x minus 1 is also a, and it's called the square root of 5b and the square root of 5b. So really we have the same pattern of a squared minus b squared if we multiply it out, or a minus b and a plus b. Right, so if we were to go ahead and multiply this out, we would end up getting this x minus 1 times x minus 1, and you would see that that would end up being this x minus 1 squared, right? That's what that would be. And then we would go ahead and subtract the square root of 5 squared. Okay, so we go ahead and subtract the square root of 5 squared. Okay, if you wanted to go ahead and FOIL out the whole thing, you can go ahead and do so. It just ends up being that the outers over here and the inners are going to cancel each other out because of this difference of squares pattern. Now, if we take this quantity of x minus 1 squared and we multiply it out, I'm not going to write out all the details. It's going to end up being x squared minus 2x plus 1. And then if we go ahead and square the square root of 5, that's just going to end up being 5. So that's going to be minus 5. Okay, then we can go ahead and combine these like terms of 1 minus 5. So we'll have x squared minus 2x minus 4. So when we multiply those two binomials together, we ended up with this trinomial. And at this point, we don't want to forget that we had an x minus 4 binomial that we haven't used yet. Now let's just go ahead and multiply this linear binomial by this quadratic, and let's see what we're going to get here, right? So let's multiply this x times x squared first. X times x squared is going to be x to the third power. Then x multiplied by this negative 2x is going to be negative 2x to the second power. Then this x multiplied by negative 4 is going to be negative 4x. Okay. Following that, we have this negative 4 times x squared. That's going to be negative 4x squared. Then negative 4 multiplied by negative 2x is going to be a positive 8x. And then finally, this negative 4 multiplied by negative 4, that's going to be a positive 16. All right, now to combine some like terms. So there's only one term with x cubed in it, so we'll just leave that one alone. Then we have some x squared, so negative 2x squared minus 4x squared, that's going to be a negative 6x squared. And then following that, let's go ahead and combine this negative 4x and positive 8x. That's going to be positive 4x. And then finally, we have a 16 at the end that didn't combine with anything. So finally, we have a polynomial written in standard form where all the degrees are decreasing as well. So we have f of x is equal to x to the third power minus 6x to the second power plus 4x plus 16. And this would be our polynomial written in standard form. Here's number 3. For number 3, we have a polynomial with a leading coefficient of 1, and then we have a few zeros here. We have 1 as a 0, 3 as a 0, and we have 2 plus the square root of 5, so that means we must also have 2 minus the square root of 5 as another 0. Let's go ahead and start by writing our polynomial in factored form. So we have f of x is equal to, our first one's going to be x minus 1 to take care of that positive 1 we have. Then we have a x minus 3 to take care of the positive 3 we have. Then for the 2 plus root 5, we're going to say x minus the quantity of this 2 plus the square root of 5. And then we're going to have one more, we're going to say x minus the quantity of 2 minus the square root of 5. So this would be the completely factored form for this polynomial. All right, just to take care of this easier one, because these are just rational values, I'm going to go ahead and multiply these out. So if we multiply x times x, that's just going to be x to the second power, x squared. Then multiply this x times negative 3, that's going to be negative 3x. Negative 1 times x is negative x, so negative 3x and negative x make negative 4x. And then finally multiplying this negative 1 times negative 3, that's going to be a positive 3. All right, so this is what we're going to get when we multiply the first two binomials together from those rational zeros. Now let's just focus our attention on the mess to the right where we have some radicals. All right, so let's just go ahead and see if we can multiply these two together now. All right, so just like in the last example, we're going to start by doing is distributing this negative on the outside, so we can go ahead and regroup and try to use that difference of squares pattern, okay? So distributing those negatives, we're going to have x minus 2 minus the square root of 5 for our first group of parentheses. And for our second one, we're going to have x minus 2 plus the square root of 5. Now at this point, we can go ahead and regroup this x minus 2 and think about it as one whole piece. So we have this x minus 2 and x minus 2 in both of these. So again, let's consider this to be our a. Let's think about this as our a. Let's think about the root 5 as b and this root 5 as b. So it looks like we have a minus b being multiplied by this a plus b, right? And so when we do that, we should get this a squared minus b squared, which is a difference of squares pattern. So you can really get away with just taking this x minus 2 and squaring it, and then subtracting this root 5 squared. That's what it ends up turning into, right? So we have the quantity here of x minus 2, and it's going to be squared. And then we're going to be taking away the square root of 5 that is squared. So that's what this whole thing is going to be turning into. Now if we go ahead and multiply this out to turn it into a trinomial, we would end up getting x squared minus 4x plus 4. Feel free to take your time and pause and try to work that out if you need to. And then if we go ahead and take the square root of 5 and square it, that's just going to be 5. So we're going to have minus 5 here. Now 4 minus 5 is going to be negative 1, so this whole thing is going to turn into x squared minus 4x minus 1. Alright, so when we multiplied these two, we got this trinomial over here, and then when we multiplied all of this together, we ended up getting this trinomial. So at this point, it's time to go ahead and multiply this trinomial by this trinomial to get the polynomial that we're looking for in standard form. Alrighty, so let's just bring down the trinomial from earlier. So we have this x squared minus 4x plus 3. Let's go ahead and multiply that by the trinomial we just found. Alright, let's start with x squared multiplied by x squared. If we go ahead and do that, that's going to be x to the 4th power. Then we have this x squared being multiplied by negative 4x. That's going to be minus 4x to the 3rd power. And then we're going to take this x to the 2nd power, multiply it by negative 1, and that's going to be negative x squared. Now this negative 4x is going to multiply by x squared. That's going to be negative 4x to the 3rd power. Then this negative 4x multiplied by negative 4x, that's going to be a positive 16x squared. And then we take this negative 4x and multiply it by negative 1, and that's going to be positive 4x. Finally, for this positive 3 times this x squared is going to be a positive 3x squared. Then multiplying this positive 3 by the negative 4x, that's going to be negative 12x. And then for this final one, we have 3 multiplied by negative 1, and that's going to be minus 3. Now let's just see if we can combine some like terms here. So I don't see anything else that's to the 4th power, so we have this x to the 4th power. We have a minus 4x cubed, and then we have another minus 4x cubed, so I think that should be minus 8x to the 3rd power, 8x cubed. Then moving on to the degree of 2, we have negative x squared plus 16x squared, that's 15x squared, right? And 15x squared plus 3x squared should be 18x squared. If we combine all those, we have 18x squared. And then now on to the normal x's here, let's go ahead and see if we have this 4x, take away 12x, that's going to be a negative 8x. So we can subtract 8x here. And then we have a minus 3 at the end, that constant, so let's go ahead and just put that on to the end. So after all that, we were given 3 zeros in the beginning with a hidden 4th zero, so kind of makes sense here, right, that we have a 4th degree polynomial at the very end here. So we have x to the 4th power minus 8x to the 3rd power plus 18x to the 2nd power minus 8x minus 3. This would be the polynomial that has those given zeros. Alrighty, here's one final example here where we have a polynomial where we have a leading coefficient of 1, and we're given some zeros here. We have 3i and the square root of 2. Now, besides 3i, remember that complex zeros also come in pairs, so if we have 3i, we also have a negative 3i, and in addition to a square root of 2, we have a negative square root of 2. So although we were given 2 zeros, keep in mind that there are really 4 of them that were given here. Let's go ahead and start off by writing this polynomial in factored form and then go from there. So we have f of x is equal to, and then we're going to have x minus, let's maybe do the imaginary ones first or complex ones first. So we have x minus 3i, we'll start with that one. Then for our next one, we'll have x minus a negative 3i. Okay, so we're going to subtract each time. And then we're going to have another one where we have x minus the square root of 2. And then finally, we're going to have x minus, and then we'll put the negative square root of 2 in parentheses here. Okay, now just to quickly take care of some of these signs, let's go ahead and just distribute or multiply that negative and negative here, as well as a negative and negative here. I just want to clean that up a little bit. So let's just take this as going to be x minus 3i, and then we're going to have x plus 3i. Okay, so that kind of has that difference of squares pattern, right? And then over here, we're going to have x minus the square root of 2. And then over here, we have x plus the square root of 2. Okay, so we cleaned it up a little bit, and let's just really focus on the left side here, maybe with the complex ones or the imaginary ones, and then we'll deal with the radicals next, okay? So if you really think about this, we really have a minus b multiplied by a plus b, right? Just consider the a as x and the 3i as b. So if we multiply this out, we really should get a squared minus b squared and get that difference of squares pattern, okay? So if you want to go ahead and write it out fully, you totally can, but x times x, that's going to get us x squared. Go ahead and write it just like this. If we multiply x times this 3i, that's going to be 3ix, and this is going to be negative 3ix, so they're going to cancel each other out. And then we're going to have this negative 3i times positive 3i, and that's going to be minus 9i squared. Okay, so that's going to be what we have over here. And then we got to remember what this I squared is equal to, right? So I squared is equal to negative 1. So if we go ahead one step further, we can say this is going to be x squared minus 9 multiplied by negative 1. And then negative 1 times negative 9 is positive 9. So we can just simplify this down into saying it's x squared plus 9. Okay, that's what this whole thing would turn into. Alrighty, so throw in some equal signs here. And then let's go ahead and take a peek at what we have to the right here with the radicals. Just like what we did with the complex values, let's think about this as a minus b multiplied by a plus b. So the outers and inners will cancel out with each other, and we'll get a squared minus b squared again. Okay, so let's go ahead and take a peek and see what's going to happen here. So x times x, that's going to be x squared. We're going to go start with that x squared. Then the outers is going to be the square root of 2 times x, and then negative square root of 2 times x, but they're going to cancel each other out. And then negative root 2 times positive root 2, that's just going to be minus square root of 2 squared, right? That's going to be that a squared minus b squared we have here. Now, the x squared is already simplified, can't do anything there, but the square root of 2 squared is just 2, so we're going to have minus 2. All right, so just lining this up with this binomial we have down here, we have this x squared minus 2. That's going to be right next to the x squared plus 9. So we started off with these complex ones over here, and that turned into this x squared plus 9. And then dealing with the radicals with this plus or minus root 2, we ended up with this x squared minus 2. Alrighty, so one final step, let's go ahead and multiply these out. So we have x squared times x squared, that's going to be x to the 4th power. And then this x squared multiplied by negative 2, that's going to be negative 2x squared. Then 9 times x squared, that's going to be positive 9x squared. And then finally, this 9 times negative 2, that's going to be negative 18. All right, so finally, I think we can just combine a couple like terms in here. So if we do that, we're going to have x to the 4th power in front. Negative 2 plus 9 is going to be 7, so we have 7x squared. And then we have minus 18 afterwards. All right, so after all that, we have our final polynomial in standard form. It's going to be f of x is equal to x to the 4th power plus 7x to the 2nd power minus 18. So there you have 4 different examples of using zeros that were given to find out the polynomial written in standard form. If you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.